Okay, the second type of polymerization we're going to look at is called a condensation polymerization. Specifically, and I would underline this in your notes, the condensation reaction we're talking about is a polymerization or a esterification reaction where we're creating an ester. If you remember back to those reactions, there's two molecules that I have, or two functional groups I have to make an ester. I have to have a carboxylic acid and I have to have an alcohol. So that's what we're going to be dealing with here, where the additions were the alkenes and the alkynes. Here we're going to be dealing with carboxylic acids and alcohols. Now, the first one we'll look at is, what if one monomer has both functional groups? So let's say I have a 3-carbon molecule like this. On this end it has the carboxylic acid, and on this side it has an alcohol functional group, an OH. So there's my monomer. I'm going to add in that monomer again. So let me do it in a different color here. Actually, I'll just show it put together. So we know that if we took this carbon chain and reacted it, that OH would come off. In a normal esterification or esterification reaction, that OH would come off, as well as the H from the alcohol, and the O would be left, and then we would have our branch. So that O is from the alcohol group on the next one. Right? It would have been this O right here that's plugged in there. And then this would also have a double bond to an O and single bond to what should be an OH there. Now that OH again is going to react though just like this one did. And so then we're going to have the alcohol from the next one, the O from that alcohol, plug in there like this. And this pattern would just keep continuing on like this. So it's essentially a molecule like a pop bottle. That'll work. So this end reacts with this end, and so another pop bottle could come over here and plug in there, and then another one, and then another one, kind of in the same sort of a chain like that. So the alcohol end is plugging in where the carboxylic acid, OH, used to be, and then another one, and then another one, and this forms our chain. So since, oh, and I should mention that at each of these junctions, we're also going to form a water. So there's an H2O there, there's an H2O there, there's an H2O there. And that's why we call these condensation polymerizations, because the reaction is creating these small water molecules. The other name that comes up quite often with these, and we don't necessarily name these ones because they can get quite confusing, but essentially what we're making is many ester linkages like this. So these are referred to as polyesters. So polyester fabric, depending on which monomers you use, is made in this way by combining a carboxylic acid and an alcohol together to form these long chains into a fabric. But it can also be used to form other things. Okay, now let me show you one more type, and this one is if instead of having both functional groups, the alcohol and the carboxylic acid, on the same monomer, we have two alternating monomers. So what if I have this monomer that has two carboxylic acids like this, and then I have a different monomer that has the alcohols. It's got one on each side like this. Oops, not. Okay. So in this case, when we form the polymer, these two are going to react, and then we would put another carboxylic acid over here, and that would react with these, and that's where our reaction is going to take place. So what this would look like would be, that O would be a different. If I show you with the right colors here. And then this would be the oxygen from the alcohol. It's chained to 3 carbons. and then another alcohol O, and that O would plug in where this used to be. And this chain would just keep repeating like this. But instead of just having the one monomer, it's alternating from one monomer to the other. So alcohol, diol, and then to a dicarboxylic acid. Don't worry about that. You don't have to ever name it, but it's just those two pieces alternating together. So those are the condensation polymerizations. They usually don't have a lot of extra stuff like branching or things like that put together, but you may have to look at one and be able to say whether this was one monomer that repeats over and over, or whether there are two different ones here that are alternating back and forth. So hopefully that makes sense. Let me show you too some other examples. In your notes, you have some examples on the next page of some common ones. So you can see on the left side there, they show you the monomers put together and then how they're put together in the chain. This part right here is kind of like an abbreviation. Rather than drawing it over and over and over again, they draw it in these square brackets. And the square brackets are just a way of saying whatever's in these brackets is going to repeat n number of times. So just over and over and over, as many as you want, potentially. This will continue to chain together. So that first one is polypropylene. That's the polypropylene that we drew when we did addition. That's the kind of plastic you'd find in a Tic Tac lid, that kind of nice, soft, flexible plastic. This one is polyvinyl chloride. So it's a it's a ethene, a chloroethene monomer. So the actual IUPAC name would be polychloroethene. And you can see what it looks like. This one is polystyrene. This is how you get styrofoam cups and containers and things like that. So it's an ethene that has a phenyl branch on it, and that's how it looks as a polymer. And then here's its abbreviation. Teflon. This is the black stuff you find on non-stick pans. Is actually an ethene with 4 fluorines attached to it. We put that together into a polymer and we get a non-stick plastic that you can put on your pans and cookware and things like that. And here's a natural example, and it's starch. So the starches in our body or in food like potatoes or breads or things like that are essentially made from glucose or simple sugar monomers chained together. Proteins are kind of like a polymer, except it's not always the same repeating unit over and over. It's varying amino acids. Those are all kind of examples of natural polymers. And I think there was some too on this page. Wool, silk, rubber, cotton, amber from tree sap, tortoise shells. Those are all naturally occurring, like found in nature polymers. Excuse me. As well as the carbohydrates and the proteins. Now, some common synthetic ones that you should know are nylon. That's a common fabric that we use for elastics and some clothing and things like that. Polyester we've talked about, that's in a lot of really durable fabrics. Kevlar is something that you would find in really, really strong durable fabrics, and that would be everything from like mountain biking or dirt bike racing gear. So those jackets and the pants and stuff that they wear are very durable, so that if they wipe out, it doesn't wear off the clothing and then start wearing off skin as they skid across the ground. It's a really, really durable fabric. It's also what they used to make bullet-resistant vests. So they take essentially layers and layers and layers of this really, really tough fabric, and they make it so many layers that when a bullet is shot at it, rather than the bullet just going through the clothing and then through whoever's behind the clothing, that it acts like a big soccer net. And so as the bullet pushes on it, all the fabric gives and absorbs that energy before it can make it through the layers of fabric. So when I say bullet resistant, it's because no vest is bulletproof. but also because it's not going to just like bounce off. This is going to hurt like crazy, because imagine your whole shirt catching a bullet like a soccer net and caving into your chest. You're probably going to have broken ribs, maybe some internal bleeding. You're definitely going to be sore, but you won't have holes. That's a good thing. And all plastics are synthetic polymers, so that's just something to keep in mind. So hopefully that cleans up the polymers. Remember that there's addition polymerization with the unsaturated monomers, condensation polymerization with alcohol carboxylic acid monomers, and excuse me. And you should know at least some of these examples of both natural and synthetic polymers, and be able to work these out both from monomer to polymer and from polymer back to their monomers.